Vaccines are designed to protect you from a virus, and the way that they succeed is by getting the immune system all worked up. But this is exactly what causes those unpleasant side effects that can knock you off your game for a day or two. So while the fatigue, headache, and low-grade fever are no fun, they can actually be proof that the vaccine is doing its job, and doing it well. Your immune system is actually already quite good at getting rid of viruses, but it isn't all-knowing, and when it encounters a new virus, like the one that causes COVID-19, it needs to be taught some new tricks. And the best way to do this is through a vaccine that tells your body what to do if it encounters the virus, essentially creating what's called a memory response.
Now, everybody responds differently to a vaccine or an infection, and so everybody's memory response is a little different. But the vast majority of people, their memory response is so fast, so strong, that it clears that infection or that virus before it really has a chance to get established. And so you won't have any symptoms. You won't even know you are infected. Hi, my name is Rick Kennedy. I'm a professor of medicine at the Mayo Clinic. I'm an immunologist by training. I study vaccines and infectious diseases, and I run the vaccine research group here at Mayo Clinic.
So creating a memory response to a virus is key. But how exactly does a vaccine do this? Well, it might help to start with an understanding of how the immune response works.
The first part of the immune system is called the innate immune system. It's sort of your first lines of defense. It has three main jobs. The first job is to recognize that you're infected and sound the alarm. The second job is to try and recruit white blood cells and send them to the site of infection to try and slow it down. And then the third, and probably the most important thing, is to take the virus or the bacteria that's infecting us and take it back to the rest of the immune system so that it can learn to recognize and then destroy it.
The innate immune system fires up as soon as the virus gets into the body. And it's that flood of immune activity that can cause symptoms like a fever or muscle aches. It sets the stage for the next phase of response, the adaptive immune response.
T cells and B cells are part of what's called the adaptive immune response. So the first part of that are B cells. They're basically antibody factories, and each B cell is specific for one little piece of one viral protein, and that's called an epitope.
The antibodies produced by B cells will bind to this epitope and can block the virus from attaching to or entering cells. They might be called B cells, but they're really the A team. Then there are the T cells.
And those are important because once a virus gets inside your cells, the antibodies can't get to it. So it's hidden from the antibodies, and it's going to turn that cell into a virus factory and produce more viruses. That's how the virus spreads through your body. You have killer T cells and helper T cells. The killer T cells hunt down and kill infected cells.
And yes, you guessed it, helper T cells help them. You want to have both a strong innate immune response and a strong adaptive immune response to fight a virus. So every vaccine needs to have ingredients that trigger both.
Vaccines have two main components, at least from the perspective of the immune system. There's the part that would stimulate the innate immune response, and that's called an adjuvant. And that's typically a molecule or a pattern that's found in a virus or a bacteria that's not present in a human.
When you're injected with a vaccine and the innate response is triggered, that's where a lot of those well-known symptoms come in. The burst of activity to the site of the vaccination is why your arm gets sore after a shot.
The other component is the antigen, and that's really the piece that we're trying to have the T cells and the B cells target and respond to.
So no matter which vaccine you get, you're getting a mixture with an antigen and an adjuvant injected into your muscle cells.
There's some specialized cells called antigen-presenting cells. They act like garbage disposals and trash collectors. They just sample the environment. So they will see the antigen and pick it up. They'll see the adjuvant and say, oh, something's wrong here. And then they'll carry the antigen to the lymph node. Lymph nodes are basically like a shopping mall. T cells and B cells are coming in and out all of the time. And every T cell and every B cell, it's looking for that one shirt on the rack, that one epitope, that one piece of the viral protein that it recognizes.
This process happens in the first few days as the B cells learn to make antibodies and T cells learn to kill cells, or how to help kill cells.
They're also proliferating, growing, and dividing, and making clones of themselves because you'll need an army of these white blood cells to fight off the army of viral particles that is present in your body and infecting you. And that whole process takes about a week or two. Now, for an infection, that's where the story ends. But for a vaccine, you're really not trying to protect you against the vaccine, you're protecting against a future infection.
Your body clears the antigen and the innate response calms down. Then, most of the T cells and B cells will die off as their services are no longer needed. But some of them will change into memory cells.
Now, memory cells will last for years, sometimes decades. They just circulate through your body and they're fairly quiet until you run into that virus again. Now, a naive cell, the first time it sees antigen and it's learning to do its job, it's a little bit like an infant taking its first steps. A memory cell, it's the equivalent of an Olympic caliber athlete. It takes off running at full speed and it's fast. So the difference between your memory response and that initial response is that the memory response is 100, sometimes 1,000 times stronger.
Okay, sign me up for these Olympic caliber cells ASAP.